Agriculture and Agri-Food Canada at the Lethbridge Research Centre in Alberta. And Paul Thorogood asked me to cover some research and discussion around nitrogen management in no-till winter wheat systems. Next slide, please. Okay, so we're going to talk about 5 key areas here. I'm going to give you a little bit of background about the global winter wheat agronomy research we're doing, and then head into areas around nitrogen losses, some new research that challenges conventional wisdom around placement and losses, and then the whole area of enhanced efficiency fertilizers. Next slide. So just this past February, the minister announced new funding for winter wheat agronomy, thanks to private sector investment from a wide range of stakeholders of winter wheat that came up and put money forward that was matched by the Growing Forward Agri-Innovation Program. And really all of these bubbles that you see around this big bubble are really topics that arose from the previous program we had, or from feedback we received from producers. And really what we continue to do is try to do tweak those practices that can enhance stand establishment or improve crop health. So we're working on a wide range of topics, from trying to better understand the risks associated with a wide range of seeding dates, looking at genetics and stripe rust management, and of course nitrogen management as well, and including some of those other questions that have arose in all crops lately, such as plant growth regulators, and there's always weed issues as well. So those are the themes of the current project moving forward. Next slide, please. And okay, into nutrient management now. So really, there's always those 4 key things around nutrient management: the amount of fertilizer you're putting down, where you're going to put that fertilizer, what is the source of that fertilizer, and when did you do it. So we're always going to be talking about one or all of those 4 keys. Next slide, please. Just a little bit of review around the nitrogen cycle. This schematic gives us a good idea of how things interact in that nitrogen cycle when we're providing either organic or an inorganic source into that nitrogen cycle, and hopefully it's being converted eventually into an available source that plant can uptake. So just give me one of those bubbles, Carly. So the bubbles that are going to come up here are those areas where we're prone to losses in this nitrogen cycle, and really they occur all along it. And one of the ones that is quite common is volatilization, and that can actually happen even in cold soils. Another bubble there, please, Carly. One that doesn't get much attention is actually immobilization. And that really is a function of the amount of trash or residue that you have on the surface. And what happens if we get too much is that soil microbes will actually stop their efforts in converting N to an available source and actually bind up some of that organic N and actually redirect it into immobilization. And that's why you can get a yellowing crop when you have a lot of trash on top of the surface. Next bubble. One that we're all well aware of is that depending on soil texture and the amount of water in that soil, we can be prone to leaching and runoff. And the last bubble, this is one that can occur that sometimes we don't really notice, and that is when we have really waterlogged soils, our nitrate actually converts to gases, and we end up with these oxide emissions, nitrous oxide emissions, escaping into the atmosphere. And those 4 areas, what is sometimes lost on people is that they can occur really in a wide range of soil types and environments, obviously, and are influenced by source and management practices, but they can also occur, in cold soils and also in the fall or the spring. Next slide. And so these next series of slides provided by Dr. Rigas Karamanos just give us some nice background about enhanced efficiency fertilizers, and why do we have the attention? Well, we always have attention around fertilizer because fertilizer prices tend to fluctuate and really influence our bottom line. But also, we're getting into these issues where it's becoming an increasingly environmentally sensitive topic around our emissions and our greenhouse gases and the contributions from our nitrogen management practices. And so at currently, and based on the research, really a best case scenario is that our efficiency of converting that nitrogen we apply is really only about 30 to 50% of what we apply is actually taken up by the plants. And so the question is, what role can enhanced efficiency fertilizers play in that and help to reduce emissions? Next slide. So what is an enhanced efficiency fertilizer? So this specific definition here, really all it is a fertilizer product that's going to allow increased plant uptake and at the same time help us reduce the potential nutrient losses. Next slide. And really, what is new about losses? Well, there's some recent research that was eloquently summarized by Rigas at a meeting that I was fortunate to attend, and he has some great slides on here challenging that old wisdom of if you've got that soil or that fertilizer in the soil, it's safe. And the reality is that really isn't the case. Next slide. Here's a good example of that. This is research showing volatilization along that y-axis and 4 different systems. And that blue bar running up and providing the highest rates of volatilization is actually banded fertilizer that was then incorporated. The second worst system was broadcast, then incorporated. And interestingly, just broadcasting that fertilizer on the surface actually improved our losses or reduced them compared to those 2 systems that we thought were the best. And we reduced them even further when we surface banned by having a stabilizer with that urea product. Next slide. Similar situation with UAN here, showing results of what's happening with placement. And again, the system that gave us the most ammonia was that system where it was shallow applied, whereas the best system, that purple line there, was when we put our UAN deep into the soil. Next slide. And so what is an enhanced efficiency fertilizer? Well, there's 3 different types here. I'll focus on the last 2 bullets there. A physical coating or barrier around that soluble granular fertilizer, such as a polymer-coated urea, and then stabilized materials, those that are called nitrification or urease inhibitors. Next slide. So polymer-coated urea. Our best example of that, at least in agriculture, is probably ESN, which is environmentally smart nitrogen produced by Agrium. And other examples of the stabilized form, the urease inhibitor, one that's been around a long time, is our agrotane. And then relatively new to the market are these urease and denitrification inhibitors, such as a Super-U. Both agrotane and Super-U now part of Koch Agronomic Services portfolio. Next slide. Okay, talking about ESN then, there has been and always will be the need or the situation where producers are dealing with a seeding system that is a single shoot, such as your older flexicoil systems. And really, in a situation like that where you're forced or you want to put your fertilizer down with your seed, the research pretty much all came up with the same conclusions, that anything beyond placing 30 kilograms per hectare was leading to issues as far as seed safety and stand thinning. So anything beyond that with uncoated urea was causing problems. However, ESN has been a real blessing for those that want to put more fertilizer down with their seed. The research we've done and published by myself or with Ken et al. Basically, anywhere from 60 to 90 kilograms of N could be put down, which is twice to 3 times what the safe rate would be. So Agrium's a little bit conservative, where they say you can put 50% more N down as a seed place compared to uncoated urea. But our research and that of Dr. McKenzie has shown that with cereals particularly, you can go up to 3 times that. There's even some research showing 4 times would still give you seed safety and no issue with plant stands. Next slide. Here's some work done by Ross McKenzie back when they had 2 prototypes of ESN. And as you can see, with both prototypes there, no issues with reduced plant populations through 90 kilograms of N per hectare, whereas our uncoated urea, the plant populations start to fall off anything beyond 30 kilograms of N per hectare. Next slide. Dr. Cindy Grant conducted some research on side banding in a canola system using 2 forms, UAN or urea, and then stabilizing those forms with Agriting. And as you can see from this, again, anything beyond, say, 40 kilograms of N using uncoated urea or UAN with no stabilizer started to reduce their plant populations. And we really want our plant populations for canola to be somewhere in the range of 80 to 100 plants per square meter. And as you can see, with a stabilized either UAN or urea, that's not an issue. No issue through 80 to 120 really kilograms of N per hectare. Next slide. One thing that we were interested in with ESN was, what about those situations where seed safety isn't a concern? So, for example, with our own research, we're using a Conservapac seeder, which is now owned by John Deere, which has our seed placed off to the side. So seed safety is not an issue, but does ESN still have a role there? And this is probably one of the first studies where we looked at blending ESN, and so next slide, please. And so what we did is we compared uncoated urea to either taking ESN and improving our input costs. We took and we blended ESN 1-to-1 or 50-50 with uncoated urea and compared that to 100% ESN or 100% urea. And in both situations, the blend was actually producing exactly the same results when we side banded. And so there's a role there with ESN, but you certainly do not have to go with 100% ESN once you're outside that seed band. Next slide. And just out of interest, if you haven't been to a field day or seen the type of research that we do, and this is typical of most of your Ag Canada research agronomists, is that we tend to strive to create real-world situations by utilizing the same types of equipment that occur on farm. And so in our case here, we're using what is essentially the midsection out of a Conservapac air drill. We're surface banding with just smaller scales of what you'd find in the commercial world, in this case at Valmar. And we try to go with fairly large plots, which actually eat up a lot of land, but I think they're quite valuable in serving that desire to achieve real-world results. Next slide. Okay, some of the results of work that we've been doing around form and placement with winter wheat. The first study here was a 3-factor experiment where we looked at one of 2 varieties, AC Radiant, which is very popular from 2001 right up and actually even still a bit today. CDC Ptarmigan was a soft white winter with very high yield potential and serving a range of end-use markets. And so we imposed two types of nitrogen systems on there. The first one was form, where we looked at Agri-Thin, Super U, ESN, and UAN compared to uncoated urea. And we either put all that fertilizer down at seeding in a banded situation with a conserva pack, or we waited till spring and put all of our product on, or lastly, we put half at seeding and half in the spring. Next slide. And so here are the results with, and really what the question we were trying to answer was, is there risk as a producer by not putting all fertilizer down? There was some concerns that a split application would result in inferior yields. And Carly, just give me the next box here. And so inside this green box, all of these systems are providing significantly similar granule. And as you can see, the numeric at the left there, the top yielding systems are actually systems with stabilizers and systems that were either sideband or split with a range of either 50-50 or in some situations there's Agri-Thin all broadcast in the spring. What was inferior, in the next box, Carly, are three systems, two of which involved the UAN. And now you have to recall the UAN wasn't a stabilized product, and we were definitely, obviously, incurring significant losses because of that. But also ESN, we don't encourage actual broadcast or surface banding of ESN. The problem is in fields where you've had a long history of no-till, you probably have quite a thick thatch layer. And if that ESN gets bound up or hung up in the thatch layer, and it's never in a situation to imbibe any water to start the hydrolysis, it could just sit there all year and not be available to the plant. Next slide. And next box. And so similar situation with protein. Our protein accumulation, we achieved results with a range of placement and product scenarios. And so again, if your desire is to go with a split application, but you're worried about yield or protein penalties, that just isn't the case. The only case where we had it next box is that, again, all systems with a UAN form that weren't stabilized. Next slide. And so what follows then is a similar pattern in relation to nitrogen uptake. So for example, if we look at, all of our fertilizer broadcast in spring actually gave us the best recovery, and particularly notable in the Super U system where numerically anyway, we had very high recovery then if we wait and put everything down in the spring. But not far behind that was typically the split application of half side-banded at seeding and half broadcast in the spring. Agri-Thin as well, looking pretty good there. ESN falls down like we would expect it to in situations where we would broadcast all that ESN in spring. Next slide. Okay, so I'm going to provide you with some other work we're doing in preliminary results from the first year. This was basically an expansion of what we covered off in that first experiment, but we've added an N form that's new to the market as well by Dow AgriScience. It's called Instinct, and we compared that with Super U, ESN, and uncoated urea. And the second factor in this one was timing and placement, where we would put it all in the fall of planting, or we went with split application. And in this case, I decided to go with less N at planting. So I was only putting 30% down at planting, and either putting 70% down in late fall or 70% in spring. The late fall one is something that, in relation to feedback we received from producers, is that in areas, particularly in Manitoba, it's far too wet in the spring to even think about spring broadcast application. So they were interested in seeing if we could overcome those severe losses that we normally incur if we try to apply any fertilizer of any kind in the fall. And that's been well documented that a product that is uncoated, not stabilized, will incur heavy losses when applying in late fall. Next slide. And next circle. So this is a scenario where along the y-axis here we have our grain yield, and then along that x-axis there, what I've done is I've superimposed a proxy for stability, and so that allows us to see how stable these treatments are across environments. And then by doing that, you create four boxes or four quadrants or groups. That vertical bar you see there is the mean coefficient of variation for all the treatments, and the horizontal bar is our mean grain yield. And so our preliminary results from 1 year in a couple locations is kind of interesting. What we're seeing there is really everything banded at seeding was providing probably our most stable grain yield, but those losses we would expect in late fall seem to either be not present in the fall, or they were mitigated by using urea-thin or Super U. And we've seen this before with Super U, where it's the only product to date that we've seen not suffering or mitigating those losses we would expect if we go in and top dress in late fall. And next bubble. And so this one just shows that we had pretty good low background levels with our check there. And that's an important feature of any nitrogen study when trying to develop a response. Next slide. Okay, so part two to this, I decided to set up a study like this with a heavy focus on liquid or UAN, because there was feedback again from some producers that we were kind of neglecting that with previous research. And so this gave us an opportunity to look at UAN and with and without stabilizers, as you can see from those various forms that we were using. And in this case, back to a situation where we either put 50%, we put 50% at planting, or we put it all in the spring. And so we stuck to a similar timing for all of those treatments because our focus here was on response to stabilizers. Next slide. And next bubble. So when you see UAN not stabilized as one of the highest numeric treatments, you know right away that you probably weren't prone at all to the losses that we observed with that previous study where I summarized results where UAN was very low yielding and accumulating very low protein. So in year one here, clearly we didn't have a situation where we were concerning ourselves with losses. But good to see we were getting very high yields with all treatments. Next bubble, and of course a nice low and variable check as well. And next slide. Okay, the last experiment then is one where we looked at seeding rates and coupling those seeding rates with UAN dribble band treatments, where all of the treatments were trying to put down an cumulative rate of 130 kilograms of N per hectare. And we were doing it by either putting 60 at seeding and 70 in the spring, or 30 and 100, or 10 and 120. And the reason and interest in this was there was some reports out there that rather than focus on high seeding rates, the focus as far as tiller management might be better served or equally served with in-crop UAN treatments. And so that was what motivated us to take a look at this. Next slide. And next bubble. So far what the research is showing us in this is that, you know, and not a big surprise, our best yielding treatments were those with the highest seeding rate, and with split applications where we put less in the fall and more in the spring, interestingly. Whereas our lowest treatments, next bubble, were those with a very low seeding rate, and almost irrespective of how we split that or how we timed that. And so again, I think it just confirms our previous research where you want to be planting at a minimum of 450 seeds per square meter. although there are situations where 300 is okay, but the reason we stress a higher seed rate, and incidentally, we're even observing good responses of 450 seeds per square meter with some of our durum and spring wheats. We like that higher seeding rate because it gives us a much better weed competitive situation and the opportunity to possibly pull back on herbicide inputs. Next slide. Okay, so these are some conclusions I came up with in relation to this whole area of nitrogen management, and really the key point there is we're really seeing good results with our enhanced efficiency forms, whether it be an ESN, an Agrotane, a SUPU, or perhaps even Instinct. But the point is there's really a role for them, and so it's really, of course, where and when you see that response is going to be dependent on your risk for loss. As you can see from some of the preliminary information there from our results from our new studies, so far we really haven't seen environments where we had high risk to loss. The second point is that there really shouldn't be a concern of needing to put it all down at planting, or that there's some sort of penalty because you're performing a split application and that you might be more prone to loss. The very fact is that some of this shallow banding, or even, which can even occur when you're planting, is also at risk for loss. And so the research we have is telling us that split applications are not an issue, and if they are of more benefit to you in your operational scenario, logistics scenario, then feel free to do that. And that's really all I have left. Next slide would acknowledge those people that helped me out with that and the research, and I thank you very much.